Yes, class. Good evening. Yes, am I audible? Assalamu alaikum. All right, class. So let's complete with interference today. See, in interference, you have one topic that is the expression of fringe widths. So fringe widths expression is left, fringe widths separation of the central bright fringe from the upcoming bright fringe is left. That we have to complete in today's class. So see, not directly we'll start with expression of fringe width. First we'll find out the separation of central bright fringe from the point where we are obtaining the wave. So it is like, this is the source, right? This is the source. This is the slit. Separation between both the slits is small d, S1. This is S2. Find the complete separation. If you take the midpoint of this, this becomes d by 2 and this becomes d by 2, half. Fine. So complete separation is small d. So small d is what? Small d is separation between both the slits. D is separation between the slits. Fine. Let's say both, this is the screen. This is the screen where you will obtain the wave. So separation of this double slit with the screen. So separation between screen and double slit. This is what? This is equal to capital D. And these are standardized variables in the sense that this is not a variable that I have taken on my. Everywhere you will find small d and capital D only. And even in the questions it will be given sometimes as capital D and small d. Fine. So whenever you're using it, whenever you're using the formula, to have it in mind to use capital D and small d, because capital D and small d can be asked to you. Now let's say through the source one, fine, through the source one, two waves will get superimposed on each other. Fine, two waves will get superimposed on each other. At the center, what will happen? You will get the first bright fringe at the center, then the dark fringe on the either sides, then bright fringes, then dark fringes, bright fringes, dark fringes. This happens. So at the center, you get the bright fringe only. Centrally, bright fringe, dark fringe here, dark fringe here. Then aside from it, then bright fringe, dark fringe, bright fringe, dark fringe, like this. So at the center, no, you obtain the brightest fringe. This is known as central bright fringe. Central bright fringe. So this separation from the screen to the central bright fringe, this is yn. What we have to calculate, this separation, this is yn. This we want to calculate before we find out what is the fringe width. Fringe width, I'll tell you, the width of the fringe, that is different. First, let us find the expression for linear separation. And this is some nth. This is nth. Central bright fringe has been formed, same thing. The way bright fringes are formed by constructive interference of two waves. Two waves are there, they constructively interfere with each other. That will result in greater amplitude, greater intensity, and all these quantities. Same thing, but just the center one, we are naming it as centrally bright. Just the naming is done. Fine. So this is linear separation of some nth fringe. Let's say this is nth fringe. We do not know which is. This is the first one, second one. Which fringe has been formed at this distance? No, some nth fringe. But we're just trying to find out the separation from the brightest fringe. That is the central one. Separation, linear separation of y nth fringe from central bright fringe. Fine. There's a separation from the centrally bright. Now we have to find the expression. Firstly, the path difference, S1P and S2P. So path difference, initially also we did it as S1P and S2P. So see, its expression first we'll write about the path difference. So that will be X will be equal to this will be S2P minus S1P. S2P is greater. So S2P minus S1P. This is what? This is the path difference. Now see, if you look at here, let's drop certain perpendiculars. Let's say I have dropped. This is for the derivation only. So never perpendiculars are dropped though. This is from the middle part, that is d by 2. Fine. This is also d by 2. This complete is small d. Let's name this point. This point will be used M. And here, this is the first fringe, so 0. Y is equal to 0. We are calculating in y is equal to 1. You will have here, you will y is equal to 2 like this. So y NH we are calculating. Now look at this triangle that has been formed. S1, NP. This complete triangle that has been formed. Look at this. So if you apply, this is 90 degrees. So you can apply normal, your simple, what you can say, Pythagoras theorem over here. But see one more thing, class. What is this separation for the perpendicular? See, complete was yn and you have subtracted d by 2. So it means this part will be, this part that is left, this part, this will be yn minus d by 2. Because this was d by 2 and complete was yn. So from yn, d by 2 has been subtracted. Now what is left? Yn minus d by 2. So we have the perpendicular, we have the base is capital D. See, this is capital D and S1P. So let's find the expression for S1P. So in triangle S1NP, if you apply Pythagoras theorem, you will get S1P square is equal to S1N square plus Pn square. This is the perpendicular. This is the separation base. This is the hypotenuse. So S1P square will be equal to, this is capital D square plus Yn minus d by 2 whole square. Simple Pythagoras theorem has been applied over here. Let's use it. Let's just expand it a bit more. So this becomes square and let's remove this sign. So S1P will become d square plus Yn minus d by 2 to the power 2. And this complete equation to the power half, just to remove as this, so as to we can remove this sign. Now see S1P. Let's write this half separately on each term. So S1P, this is equal to d square by half. I have taken d square to the power half common from here. Fine. Yes. Yn. Let me explain you Yn first. Then only you'll be able to understand the derivation. See. Through the slits were there, 2 slits are there. Sources of wave through the source, between these 2 slits, what happened? Waves went. Now waves superimposed each other. Wherever they imposed each other constructively, means crest with crest, trough with trough, resulting in greater amplitude, resulting in greater intensity. There we obtain bright fringe. And places where it is destructively interfered, you can say, or colored bands are not there, that dark space, that is known as dark fringe, that we obtain. So whenever Young's double slit experiment is conducted, or whenever this was conducted, what happens? You obtain one bright fringe, one dark fringe, one bright fringe, one dark fringe. Like this, you keep on obtaining this. Now what is happening? Just remember one thing. How will you start? Will you start at the center with the dark one or a bright one? How will this alternative sequence will go on? So remember one thing. At the center, in any case, you obtain bright fringe first. So bright fringe is there. Then on both the sides, there will be dark fringe. And again, bright fringes, dark fringes, bright fringes, dark fringes. Like this This will be the complete Young's double slit experiment. Now, this first one, what did we do in the last classes when we were finding out expression for phi as 2n pi, for all these 2n pi and like this? N was what? N was the number of fringes starting from 0, 1, 2. Why 0? 0 because we know until and unless we make this as 0, then only our phase difference will match to the conditions of constructive interference. So this means y is equal to 0. That is, there is no displacement. There is no separation. Yn is what? Yn is the separation of any of the fringes that has been formed above with the central bright fringe. Fine. So at the center only, what will be the separation between central bright fringe and the linear separation? Nothing. It will be 0. So y is equal to 0. Let's say at a distance of 5 centimeters, you're obtaining a dark fringe. So I'll ask you to calculate the separation of the fifth dark fringe from central bright fringe. It means central bright fringe, one dark fringe, then bright fringe, second dark fringe, third bright fringe, fourth dark fringe, fifth bright fringe. Like this, you'll obtain the fifth dark fringe. So n will become 5. You will obtain somewhere here, let's say here you will obtain some dark fringe, fifth dark fringe that I'm asking you to calculate. And here is your central bright fringe. So this separation is known is yn, what we are trying to calculate. So at the center, since the separation, this is yn some distance. At the center, this is overlapping. So this will be 0. Now the values will begin. Let's say we'll obtain the first dark fringe here at a distance of, let's say, 2 centimeters. Then first bright fringe here, second dark fringe here, second bright fringe here, like this. Is it clear now? Yn meaning to all of you?
Yes, teacher.
Okay. So if you have any doubts, please let me know. So yes, now proceeding with the derivation which I was discussing. So d square to the power half is there. Now I have taken this common. So 1 will be left from here. And yn minus d by 2 whole square by d square, because I have taken d square common. No. So if I take d square common, this term will be left to the power half. Now, binomial expressions, are you all aware of binomial expressions will be used here? Twice, I think it will be used. So 1 plus x to the power n, if you have, that is written as 1 by nx. This is binomial expression. So students who already have mathematics, they must have studied binomial expressions in detail. You all must be having difficult questions on binomial expression. So now we apply binomial expression here. The same thing. So this becomes what? To the power n. So here power is half. Half of the root, that power. That will come here. So see, and 1 plus same thing is satisfied. 1 plus x to the power n. N is half, x is this term, and 1 is this term. When I hover the cursor, are you able to see it? Or this is not visible if I'm hovering it? Is it visible to all of you in the screen? If I'm moving it? Yes or no?
Sorry? Yes.
No, it's not visible. Okay. See, it is not visible. Okay. So I am pointing here. This term is x. This term, the power is half, that is n. And this is 1. So 1 plus x to the power n is satisfied. So 1 plus nx. Now see, S1p is equal to d. So this is 1 plus. Now half will come. Nx is there, no? So half. Now your x, yn minus d by 2 whole square by d square. So the cursor is not visible to all of you, then it becomes very difficult. How are you able to see it if I'm pointing to something? Salman.
It's visible sometimes, but then while you're moving your pen and writing, then it's not visible.
Okay,
like now, it's in like text form, right? We can see your cursor.
Yes. Right now, Salman?
Now we can only see a point, but it's like side of the boundary.
Point you are able to observe, that small dot. Where am
Yeah, it's on the right side. But then when you start writing, it will just stay there.
Yes, yes. Okay, okay. Then it's fine because when I'm explaining it, I want that you should be able to see. Salman
No,
is with computers,
then
no?
yeah, I'm taking computers.
Because here the under the tool controls and when I'm sharing the screen, that is not appearing. In other batches that appear in the other meeting ID. In this meeting ID, it does not appear. So I have to use this only. That's why it becomes difficult here. Okay, anyways, now coming to the next triangle. So S1P, this is clear, I hope. Eight 30 p.m. means for here it is half an hour before the class ends. 8:30 is KSC timings.
Like what, teacher? End of the class or?
No, 8:30 is for us it will become 10 o'clock. Okay, okay. Okay, Sana. Fine. Just inform me before leaving. No, just inform me. Now let's say this point is some point M. Now, again, in this triangle, if you observe, same thing will occur. Hypotenuse is there, perpendicular is there. Now, see here, this will not be y1, yn minus g by 2. This part was g by 2.
Now, ma'am, now we can't see your cursor. Get it?
Okay, okay. While writing, it is not there. Okay.
Like while you're moving it. Yes.
Okay, okay. So this part is d by 2. Now see, yn plus d by 2 will be there. No, now this was already yn, and then we are adding this part d by 2. So that complete becomes yn plus d by 2 entire. Earlier it was yn minus d by 2. So in this triangle, for the expression of S2P, we are actually trying to find out the path difference. So S1P's expression, we have it. Now we want to find out the expression for S2P. So for S2P, we'll use the triangle S2MP. So S2P whole square is equal to S2M whole square plus PM whole square. So S2P whole square, S2M, again, this is also D square, plus this will become same derivation, just a plus sign will be there. Yn plus G by 2. Yn by plus d by 2 whole square. So for S2P's expression, this will become half, all the same expressions. S2P, this will become d square plus yn plus d by 2 whole square. This will be under root. D square I'll take common because I want to use binomial expression. So plus d by 2 by d square. This is my x to the power half. Fine. And this is d square to the power half, or if I write d also, that will also go, because writing d square to the power half and writing it as d both have the same meaning. Now I'll use the binomial expression, and S2P's expression will be what? This derivation comes, though this is a very lengthy derivation, but it can be asked. So steps when you will write it, no, this is actually not lengthy. It is appearing lengthy because of the long brackets that we have. Otherwise, derivation is very small. From one triangle, expression of S1P. From the other triangle, expression of S2P, which is 1 plus 1 by 2 yn plus d by 2 by d square. And this is square, no? Here we have square. Fine. So this is the expression. So we have both the equation. And for x, we already knew that this was S2P minus S1P. Now expressions are there. So we just have to place it. So x will be equal to d 1 plus half yn plus d by 2 by d square. Minus d 1 plus half. Here we'll have yn minus d by 2. Yes, here we had plus, we'll have minus d square. This will be, this won't be under complete square. Yn minus d by 2 whole square, d square, and this. Now we just have to fill this. So see, plus d from here, plus d from here. Plus d minus d, this will become what? This will get cancelled. So plus d and minus d will get cancelled. Anything else? 1 will also. Plus half, minus half, plus 1, minus half. All these terms will get cancelled. So see, x will be d 1 plus half yn plus d by 2 whole square by d square minus 1. So if we take d common also, so minus half yn minus d by 2 whole square by d square. Right, I hope I'm not missing any term. If I just miss any term, no, just point it out, because otherwise you'll copy the same. So x will be what? From here we have d. Let's take 2d square common. Half d square, let's take it as common from here. So see, this will become what? D into 1 by 2d square. And what is left here? Yn plus d by 2 whole square minus yn minus d by 2 whole square. So d and this d will get cancelled. Fine. Now see, if you open up the brackets, no, it's like a plus b minus a plus b whole square minus a minus b whole square, this identity. Now see, if you will open up the bracket, this will be 1 by 2d. See, a plus b whole square, let's write it first. So yn square plus d square by 4 plus 2ab. So 2ab minus, I'm already multiplying it with minus. A minus b whole square is there, but because of this minus, I'm already multiplying it. So again, a square plus b square. So plus into minus becomes minus b square minus 2ab. So minus into minus becomes plus 2ab. So some things will get cancelled now. Yn square, this. What is left here? This 2, and this 2. So x becomes, this becomes 2 yn small t by capital T. Yes, this is the expression, and mostly this expression will be directly used. So this x is equal to path difference is equal to linear separation into the separation between the slits divided by the screen. And from here only you can write the expression of yn, which is xd by small d. This is the expression, linear expression of any fringe. So if suppose you have first fringe, second fringe, any fringe you have, you can calculate it from here only. So yn is equal to xt. Now from here, if whatever you want to calculate, you can calculate it. Like if I'll tell you, for example, you have a bright fringe if you want to calculate. So you already know what's the path difference. Path difference is n lambda. And now you have the expression. So keep the expression yn was xt. That becomes n lambda d by d. So if you have the first bright fringe, let's say, for the first bright fringe, so you will put n as 1, so that becomes lambda d by small d. For second, by 2 will become 2 lambda d by d. Like this, you will obtain all the expressions for it. If you have sufficient data, you can calculate. But if it is for dark, so x will be 2n minus 1 lambda by 2, right? So yn will become what? X capital D by small d. So x capital D by small d. This will be the expression for the dark fringe. This is for bright fringe. because we use the formula of path difference for a bright fringe, and this is for a dark fringe. Fine. So from here also, anything if you take for first one, for second one, whatever you obtain, like if you take it for first dark fringe, so y1 will be equal to what? 2n minus 1. So 2 into 1, 2, 2 minus 1 is 1. So that becomes lambda capital D by 2 small t. Or if you take it for, let's say, for the second one, so that becomes what? Y2. 2 into 2, 4. 4 minus 1, 3. 3 lambda D by 2t. Like this. Now, do you understand what we have calculated right now? Yn was what? Any separation can you calculate now from the central bright fringe? Any separation you will be able to calculate. See, this is exactly actually what? Again, I'm repeating. Please understand this one. This is the last time I'm repeating this. You'll have so that you can understand. At the center, here you will obtain a dark fringe. Centrally bright fringe. Here you will obtain a centrally bright fringe. Fine, at this particular. Now what will happen after this point? Here you will obtain dark fringe. Here also on either side also you will obtain dark fringe. Then after this you have obtained, then again you will obtain bright fringe here. You will again obtain a bright fringe. Here you will obtain a bright fringe. Then again on either sides you will obtain dark fringe. So here you will obtain a dark fringe. Then here also you will obtain a dark fringe like this. Now see, this was your central bright fringe. Fine. This was your central bright fringe. This is your central bright fringe. Fine. This is central bright fringe. Now this becomes first dark fringe. Fine, this is first dark fringe and this is first dark. Why? Because both have obtained simultaneously. This becomes first bright fringe. This becomes first bright fringe. This becomes second dark fringe. This becomes second dark fringe. Do you get it? So when we are using the term N, because both are obtained simultaneously on either sides of central bright fringe, so you can get any number. If I say calculate the first bright fringe separation from central, so use the expression that I have told you. So that means you will obtain this separation. This will be YA1 for the bright fringe. Clear till here or not? Meaning, expression, everything. Yes, Khalid, Salman, it's clear. Khalid clear. Sana clear? Any doubts you all have in between, please let me know. Write it down. And in the questions, please be careful whether it's bright fringe is asked to you, dark fringe is asked to you, because expressions get changed for it. Yes, class. Now this was the separation between the fringes. What is the length or the width of the single fringe if we talk about? So that we want to calculate. So how can you calculate the width? See, if you look in this diagram only, if I have this entire length, let's say, see if this is y1, fine. I want to find out this. So if I subtract this yn minus 1, so I'll get this distance, that is the width of the fringe. That is what we are trying to calculate. Separation between two consecutive dark fringe. This is one dark, let's say this is one bright fringe, or let's talk about dark fringe. This is first dark fringe. This is second dark fringe. So this separation is known as fringe width. The separation between two fringes. No, here. Look here, Sana. I just look in the camera on the screen. See, you have central bright fringe, then one dark, another dark. Then you have another bright, another bright. So fringe width means thickness of the fringe, in the sense that this is not how much thick a fringe is. Width of bright fringe, if I say what is the width of bright fringe or what is the width of dark fringe, that means the separation between consecutive fringes. It means separation between first dark and second dark. First bright, second bright. If I say third, so third and fourth, or second and third, the consecutive separation between two consecutive fringes, either bright or dark, that is known as fringe width. So if let's say first dark is here, second dark is here, so this becomes the fringe. Is it clear what is the physical meaning of it? Okay. So let's write it for bright. See, both have the same formula. I am doing it from bright one. You can use it from the dark one. Both will give you the same formula. Because see, separation is same. Now here, bright and dark have no significance. So width of fringe. Three small topics we'll be doing it simultaneously. One is this width of fringe. So let me consider bright one. I am considering bright fringe right now. So it means beta will be yn minus 1. Fine. So yes, fringe width is what? It is the separation between two consecutive dark fringes or bright fringes. So if I'm talking about bright fringe, so it is the separation between two consecutive. Let me take dark fringe only, because bright fringe you will be able to calculate if we practice dark fringe. Bright fringe you can do it on your own. Same thing is there. Let me take dark, because dark can be difficult. So width of dark fringe will be separation between two consecutive dark or bright fringe, depending on whatever is the case that is taken. Now for dark fringe, I'm doing this derivation, the proof of it. For bright also you will do same thing. So beta is represented, this is denoted through this symbol beta. Yn will be what? 2n minus 1 lambda capital D by 2d minus yn minus 1. Your n is now n minus 1. So this becomes n minus 1, then this minus 1, and then you have lambda d by 2d. Do you understand why this is written? This is 2n minus 1. 2n minus 1. So since n is n minus 1, that's why 2n minus 1 minus. The way we write now, 2n minus 1. So n is over here is n minus 1. That's why. Now you just have to open up the brackets. 2n minus 1 lambda by d, or let's take lambda d by small d common. Let's take this common. So lambda capital D by 2d is left. Here you have 2n minus 1. From here, if you open up the bracket, and if you'll open up minus 1 will become minus 2 n, and this minus 2 minus 1, that becomes 2 plus 1. Here you have when the bracket gets open, so that becomes plus 3. So what are we left with? 2n, 2n gets cancelled. This becomes 3 minus 1, 2. So 2 lambda capital D, 2d. Yes, this is the final answer. Beta is equal to lambda capital D by small d. This is the final form for it. And this is same for bright and dark. Noted, then only we'll discuss the other things. Note down this. See, angular fringe width is left. See, angular fringe width means this is your central bright fringe. Fine. This is the central bright fringe. The angle that is subtended by the central bright fringe, this theta, this is known as angular fringe width. This will remain as capital D only. So for this is basically beta by capital D. You can say length of the arc by radius of arc. Based on this only, this is established. So theta is equal to beta by D, you can say, or beta you can write it as lambda capital D by small d. So capital D gets cancelled. So theta is equal to lambda by small d. And lambda is the wavelength, you already know. Yes. I just take the recording from me, or you can take it on from YouTube directly. Fine, you can listen. One more thing, class. Before one numerical we do, if somehow your apparatus is kept in some other medium, somehow in some other medium, entire YDS experiment, this entire apparatus is kept in other medium. So YDSE, if this is kept in immersed in a medium, and let's say the refractive index of this medium is small n, fine. So beta in air, that is the fringe width in air, is lambda capital D by small d. If it is in some medium, so it will become lambda capital D by small d. Here there will be an n. It means beta in air, this is what? This is equal to, beta in medium, not here. So beta in any medium, this will become beta in air divided by n. So it means now this is in the division. So this means what? When it will get divided, so it means the angular fringe width, this is decreasing, not the angular fringe width. Directly the fringe width will decrease. So in your theoretical questions also, if it is asked what happens to the fringe width if it is kept in some other medium, that means directly you will write this will decrease. Note it down, then we'll do some numericals on it. At least one numerical leads to it. See, every data is given to you. Lambda is given, small d is given, capital D is given. Actually, this was given in the form of figure like this. It was given in the form of figure like this. So all the things that were required, I have written it already. So linear separation of second bright fringe from central maximum. See, this means what? Firstly, let's take out what all quantities are given. See, lambda will be 6,000 into 10 to the power minus 10 meters. So that makes it 6 into 10 to the power minus 7 meter. Then small d was 10 millimeters. It means 10 into 10 to the power minus 3 meters, which is written as 10 to the power minus 2 meters, and capital D was given as 5 meters. So for the first part, for bright fringe, we have this equation n lambda capital D by small d, and n is 2. So y2 will become 2 into 6 into 10 to the power minus 7 into 5 by 10 to the power minus 2. So 10, 6 into 10 to the power minus 4 meters. This is for the bright fringe. Now coming to the dark fringe. So we'll use the equation of the dark fringe. So second part, yn is equal to what? 2n minus 1 lambda capital D by 2 small d. And here n is again 2. So y2 will become 2 into 2 minus 1. Lambda was 6 into 10 to the power minus 7. This is 5, 2 into 10 to the power minus 2. This becomes 3. This is 4 minus 1, 3. 3, this is 9. And here we get, then this is 75, right? Yeah, this is multiplied by 5 then, and then this 3. So 75 into 10 to the power minus 5 meters. Please check the correct calculations
Ma'am,
once.
it's 45. 45 into 10 raised to minus 5.
Oh, okay. Yes. 45. Third part was beta. That is fringe width. So 6 into 10 to the power minus 5 into 5. Small d is what? Small d is 2. Only 10 to the power minus 2. No, 2 won't be here. This is 10 to the power minus 2. So 30 into 10 to the power minus 5, 3 into 10 to the power minus 4 meter. Last part is theta. Theta is lambda by small d. It is written as beta. Instead of writing it as beta, just write it as theta. Theta is capital D by small d. So lambda is 6 into 10 to the power minus 7. Small d was what? 10 to the power minus 2. So this will become 10 to the power 10 to the power minus 2. So 6 into 10 to the power minus 5 radian. Do not write it as meter. This is radian. If somehow, let's take n refractive index is given as 2. So what will be beta in that medium? In that particular medium, if we are calculating beta. So that beta in the particular medium will be beta in air divided by 2. So in air, it was 3 into 10 to the power minus 4 by 2. That is 1.5 into 10 to the power minus 4 meter. Fine. So all the directly formula based like this only questions come. It's just that one single part will be given, complete diagram will be mentioned. Yes, from here, note it down. See, there's one topic known as sustained interference. So this means what? Bright and dark fringes, no, they have good contrast. It means they are very well separated and their intensities do not change. So again, coherent sources are there. Okay, I'll write down this and I'll explain. Otherwise, this will become confusing because this is just theory part. It can be asked in your 2 markers. No, that's why I'm writing. This is not so very important, but it can be asked. But again, I'm telling you, this is not very important from your examination perspective, from your board examinations perspective. So it is in sustained interference, bright and darks have good contrast. They are well separated. You'll observe, no, sometimes, no, what happens when the interference experiment is done. The central bright fringe looks a little brighter, and the other fringes, not the dark fringe, the bright fringes, first, second, third, all the fringes, they appear slight vague, and slowly intensity keeps on decreasing at that. But in sustained interference, the bright and dark fringes appear very clearly. Even the fourth, fifth, sixth, nth bright fringes appear very clearly, and intensities also do not change. Their intensities. Their intensities do not change with time. Now, when the question comes on sustained interference, so write complete thing, this definition, and write the conditions also. 4 to 5 conditions are there. Yes, 5 conditions are there. First is sources should be coherent. Again, sources should be coherent. Secondly, sources should be monochromatic. Also, the width of the slit, no, that we take small d, the slit width, that should be maximum. Then only clear fringes will be formed from this double slit. So slit width should be maximum. Fine. Also, small d should be maximum as well as capital D. Capital T is what? Separation between the slits, no, double slit. So that should also be maximum. Separation between double slit and screen, this means capital D. You all know, and this is small d. This should be large. Fine, note down these. This was also one topic that can be just as in your 2 markers. Very less chances though. If you have time, do revise it. But whenever it comes, no, straight away write all these points. All right, note it down. Yes, class. Now interference with white light. See, if we use simple white light, no, then what happens? Dispersion. We have already studied in case of ray optics. So when we were studying dispersion, what did we study? Then when white light, that white light is composed of all the 7 colors. So what happens is that if you use a white light, no, so all the 7 colors here in this order of the rainbow, Vibgyor order, the same order, this Vibgyor order, this complete order of the 7 colors, they'll pass through, and here at the center, it will form central bright fringe. This will be white. Fine. Then here violet will come, then indigo, blue. Like this, all the colors will keep on moving. Same thing here. This is what is known as interference due to white light. So on using white light, central bright fringe would be white. Fine. Next fringe would be violet. After few bright fringes, pattern disappear due to overlapping. After this, so sometimes the intensity is not very high. It is not constant. This will fade away like this, no, like this. It will fade. This is known as interference with white light. If we use a white light. All right, note it down. All right, class. Now, intensity distribution curve is the topic. I think this will be the last topic for today. Two numericals will be left that we'll do in the next class along with diffraction. So let's complete this topic, intensity distribution curve. So major portion of your interference will be completed. Now see, if you have intensity distribution curve is a curve that tells you the intensity variation for bright fringes, for dark fringes. Now see, if you have two identical sources, then see, I is what? I is under root I1 plus under root I2 whole square. This is the formula for bright fringes. So if it is identical, so it means I1 is equal to I2. If I1 is equal to I2, I will be what? I will be 2 under root I1 whole square. If this is the case, so I becomes equal to 4I. If you have dark fringes, this is for the bright fringes. If you have dark fringes, so see, for dark fringes, same thing with the negative sign, under root I1 minus under root I2 whole square. So if both are identical, then this will get cancelled. I will come out to be zeros. This is for dark fringes. This was for bright fringe 4 times. And this is for the which one? Dark fringe, 0. All right. Now, if you have two non-coherent sources, this was for two coherent sources, two identical coherent sources. Now, if you have two identical but non-coherent sources, these are still identical. This is also identical. Fine. Now, see what will happen. If you have two non-coherent sources, we'll write the complete equation for intensity. That is I1 plus I2 plus 2 under root I1 I2 cos phi. This is how we write it. Now here your phi is variable. Remember, phase difference is not constant for coherent source. So this is variable. Now, if it is variable, whenever we have variable things or we have more than a single value, what do? We calculate the average. That was what we did in case of alternating current as well, when we had different values of EMF, different values of current. So here also we'll take the average of all this, or average of this entire term. This entire term's average cos phi. This entire term's average. See, no need to calculate the average of this term. Cos phi is average only, we write. So you can write this out of it. 2 under root I1, I2. We'll write down the average of cos phi. That will suffice our answer. Why? Because we know what's the average of cos phi. See, class, whenever you have it, no, for cos phi, remember, minus 1 plus 1 by 2, we write it as 0 whenever we have average of cos phi. It means this entire term is 0. So IR is what? This is I1 plus I2. This is the average of. Now see how the curve will look like. Maximum was 4I and then minimum. See, this is how the curve looks like. The intensity distribution curve. This is intensity. This is the phase difference. This is the maximum 4I. And this is valid for coherent. So see, 4I maximum, bright fringe you are getting. Then for pi, you are getting a dark fringe. Then again, 4 pi, 4I maximum for coherent, for dark, for bright, for dark. Like this will move on for coherent source. And non-coherent, what did we see? It was I1 plus I2. I1 plus I2 means what? Is there any phi? No. So it means phi, it is independent of phi. The average intensity, no, in case of non-coherent sources, this is independent of phase difference. So that's why if it is independent, how the graph will look like? Graph will look like a complete straight line. That's why this is the graph for non-coherent and this is the graph for coherent. 4I maximum. See, all the intensities are at 4I only. Because this is the maximum value. So pi, 2 pi, all this is the phase difference, minus pi, minus 2 pi on the graph like this. Is it clear till here? Khalid, Memuna, Salman, are you there?
Yes.
Clear? Khalid, clear to you?
Yes, teacher, clear.
Okay. So note it down. Any queries you have, let me know. This you have written it. No, from here you have. Class on next Wednesday, you will be having the test of wave optics, complete entire lesson. I'll leave diffraction because diffraction, we are going to do it on Monday. So except for diffraction, interference and Heinz principle. These two topics will be covered. And diffraction is also a very small topic. Even I think you should be able to manage with that. So Wednesday is fine for you all or next Monday, the entire lesson?
Next
Just
Monday, please.
Monday. Wednesday is fine for high level. Okay, Monday. So what's the date? Check. This is 14th on this Monday, no? So 14th on this Monday, then 16th you have the class on Wednesday. So 21st. Fine, 21st I'll take the test then.